Okay, today's January 17th, 2012. This is the last lesson we're going to be doing for the entire course. So there we go, we're almost done. We're working on present value. Okay, present value is similar to an annuity. It's just kind of the opposite of what we were doing yesterday. Yesterday we were depositing money with regular payments and seeing how much it'd be worth in the future. Today we're doing the reverse. We're putting in, imagining a present value. So how much money do we need today to be able to live off of a certain amount by making withdrawals? So the regular payments, in this case, are talking about withdrawing money every certain amount of time, every period. So let's say, remember we were talking about the cash for life? Let's use that cash for life example again. They had said they were going to give you a certain amount of money instead of paying you $1,000 a week for 25 years. Okay? Now, realistically, let's say again, I think the amount was around $700,000. Let's say this time they said they're going to give you $700,000. Actually, let's make sure we get all this. I know we didn't quite talk about it. Cash for life gives you $1,000 a week. Okay? So that's for 52 weeks, you would get $52,000 a year. And then they give you it over the course of 25 years. It's considered a life sentence, okay? So 25 times 52,000. So over that time, they give you $1.3 million, okay? Now, obviously, they can give you, if you were to put this money in the bank, every $1,000, you would gain interest on it, and it would actually be worth more. But let's say they decided they're going to give you $700,000, okay, instead. So what we're going to do, we're going to calculate what taking $1,000, what the present value of taking $1,000 every month, or every week, and compounding it in a bank account. So let's say we have a normal bank account that gets about 2% interest, and it's compounded. Let's say for the sake of the argument, it's weekly. Okay, so you have a bank account that compounds 2% weekly. Okay, you're going to say we're going to keep this money for 25 years again. Okay, how much money would they need to give us now in order for this to be worth it? Okay, so the regular payments would be that $1,000 every week. So we're going to set up all of our variables here. Our large R would be $1,000. So I'd be withdrawing $1,000 a week. So this is like living off of this amount of money the same way Cash for Life would pay us. Regular payments, capital R. Okay. Our small r is the interest rate. So they're giving us 2%, which as a decimal is 0.02. Our years are 25 years. Okay. And a compound period. This one is compounded weekly. So how many times a year does that mean this gets compounded? 52. That's right. 52 weeks in a year. So this bank account is compounding your interest weekly. That's not bad. That's nice that they do that, actually. Now, in order to put it into this formula, right, this is a little different than yesterday's formula. We again have to solve for I and for n. Okay. So our I is the interest rate divided by the compound periods. In this case, that's 0.02 divided by 52. It's going to be a very small fraction, this number, okay? Every week they're going to give you a very small amount of interest. 2 divided by 52. Very small number, 0.12346, okay? Very small number. The number of compound periods is actually going to be very high. We're going 25 years, and because it compounds once a week, that's 52 times a year. Sorry, that's not C, that's N. So the number of compounding periods over the course of this annuity is going to be very high, 25 times 52. 1,300 times we would get interest. Okay?
So each week you get 0.1.
That's how much interest we get every week, yeah.
On the $1,000?
On the amount of money in. We deposit, or we're withdrawing $1,000 every time. So we're trying to figure out what the present value would be worth. How could I live off $1,000 a week for 25 years? Okay? They're willing, the Cash for Life is willing to give us a payout of $700,000 right now. I got to see if I can live off of that the same way as if they had paid me $1,000 a week. Okay? So what we're saying here is we take our present value formula.
Why are you taking that formula? So is that the formula on top?
Yeah, there's a formula on top. Same formula? Yep. So we're trying to solve for the present value. What would be the equivalent amount of money right now to be able to live, to take out $1,000 a week from that bank account for 25 years? Okay, we're trying to see if this would be worth it. What the present value would be. So our regular payments we said were $1,000. So every week we take out $1,000. Sorry, you don't need to put a dollar sign there. 1 subtract bracket 1. Now this is 1 plus I. I'm just going to do this in one step. Because 1 plus this decimal is just going to be 1.0003846. This is to the power. So our n here, which is 1,300, is actually a negative number. Negative 1,300.
So why are they negative? They're taking out.
Okay? It's negative because remember it's going to be flipped. It's going to be 1 over that number. Okay? This is a present value, so we're solving for an amount of money right now. Okay, so our I again on the bottom is 0.0003846. So this was a little complex, okay? I wanted to relate it to something you guys have heard about before. So we're going to solve for the brackets first. Present value is equal to 1,000. 1 subtract. I'm going to put this number into the calculator. 1.1233846 to the power of 1,300. Oh, I gotta redo this one. 1.3846 to the power of 1,300, and it's a negative number. Equals. When you put the negative number, you might have to put the negative first on your calculator. Mine had to do it second. So the number we got is 1 subtract 1.60660109. Okay, we're going to try to stay relatively accurate as we do this, okay?
What did you do? You did one way.
So we're doing this one step at a time. Is equal to 1,000. 1 subtract 0.60660109. Okay, we're being very accurate here. 0.3939891. Okay? Now, this is our fraction. I need to multiply 100 by that number on top before I divide by our I.
Wait, so what did you do?
It's 1 subtract this.
Oh, yeah.
Take that number, multiply by 1,000. All that's going to do is move the decimal place 3 spaces over. So we have 393.39891 divided by 0. Okay, so when we divide this, we get 1,024,412.63. So let's make sense of what we've just done. Remember, the Cash for Life lottery. So the Cash for Life lottery. Remember, when we calculated, at the end of 25 years, they were going to give us $1,300,000. What we were saying is, if they give us $700,000 now, would I be able to live off, if I put this money into a bank account that earns 2%, could I take $1,000 out every single week for 25 years? Oh. And what this is telling us is no, I would need to deposit $1,024,412.63 into this bank account in order to withdraw $1,000 a week for 25 years. So they are giving us enough money. That's not a good payout for us. We don't want to take I think I typed the wrong number in the calculator. It's a little less. It should be $21,022,000. That's all right. The idea is still the same. They would still need to give us this amount of money. Okay, let's play this scenario. This might be a little clearer to understand. You plan to retire when you're 65, okay? A psychic has told you you only live to 75. So how long are you going to live while retired?
10 years.
For 10 years you're going to live, okay? Unfortunate, okay? Let's assume this psychic's going to be right. You have a savings account that earns 2.5% quarterly. You would like to withdraw $8,000 every quarter until your supposed death, okay?
How old are you right now?
20. What you need to find out is how much money will you need to retire with in order to be able to do this. So how much do you need at 65 years old?
What's what you need to be retired with?
Yeah, so how much has to be in that savings account when you're 65 years old to be able to do this? And we're going to say that this bank account, this percent doesn't kick in until you're 65. So that you'd be able to retire for 10 years and take out $8,000 every quarter. Okay? And just remember this lump sum. So what we're trying to find is the present value at 65 years old. So at 65 years old, what amount of money do we need to be able to do this? So, we're going to be looking for the present value at 65. Our R in annuities is regular payments. What is R for PV? For present value. It's regular starts with W. Withdrawals. Yeah, this will be our regular withdrawals. So, how much do we plan on withdrawing every quarter? $8,000. So in this case, our R is $8,000. Okay. How many years is this going to be going on for? 10 years. Good. Compound period. How often are we taking money out and is this being compounded? It's the same time. 4 times a year. So this is quarterly. So this means this will be happening 4 times a year. Okay. So we have our R, YRC, and our interest rate was what? 2.5%. So as a decimal, 0.025. Okay. So we have that information. We need to solve for I. I is 0.025 divided by the compounding period, which is 4. Divided by 4. So this is our I. 0.00625. Is that what the number reads? I can't quite read it.
65,
Yeah? And our N, the number of compound periods, is years times compound periods. So this is for 10 years, 4 times a year. What's our N going to be? 40. Good. Okay. So the important ones. Oh, my voice. The important ones. Regular payments, I, and N. Okay? Those are the 3 we're going to be plugging into this formula. We're trying to figure out how much money we need to retire with. So the present value is equal to regular withdrawals are going to be $8,000 minus 1. I'm just going to put this right into the decimal. 1.00625 to the power of negative 40. And again, our I is 0.00625. Okay? So this is complex. We're going to do this one step at a time on the calculator.
Shut up, man.
8,000. 1.00625 to the power of, make sure you guys know how to do this, negative 40. Okay? So I get this decimal number. I'm going to go to several decimal places because I want to keep this as accurate as possible. So we're subtracting 0.7794. Okay? Then I got a 0 there, so that should be good. Divided by still our original I. Okay. We're going to subtract 1 in that number, so we get 1 subtracted by 0.7794. So in our next line, it's going to read 8,000 multiplied by 0.2206. And it's going to be divided by okay. We're going to multiply that number by 8,000. We get 1,764.8 divided by 0.00625.
Yeah.
00625. So 282,368. That's comma. So what that means is, at 65 years old, to be able to withdraw $8,000 every quarter for 10 years, that's how much I need to retire with. I'm going to have $0 left at the end of 10 years. Yeah, we're going to gain interest, though, every quarter on this amount. So I'm going to explain how that makes sense. Remember, we're withdrawing $8,000 every quarter for 10 years. So how many withdrawals do I make over 10 years if I withdraw every quarter for 10 years? That's right. It's the same as our N, right? And we're actually withdrawing $8,000 every time. So we're going to actually figure out how much of money I've actually withdrawn. That's supposed to be multiplied. Okay, so we got 1, 2, 3, 4.
4 times
Yeah. So this is how much money I actually withdraw in the end. I actually end up withdrawing $320,000, which is more than I needed to put in. The reason I was able to withdraw more money than I actually put into the bank is because it earned interest. So over the course of that 10 years, we're going to figure out how much interest we actually earned. We take that $320,000, which is the total amount I actually withdrew, and I subtract it from the amount I originally put into the bank. What is it? So, over 10 years, I earned $37,632 in interest in this bank account. Not a bad deal. I didn't have to work at all. I was retired, and I still earned money.
But did the guy die?
In the end, he ended up living, and he won the lottery. What a lucky guy. So let's say you won the lotto. Lotto Max in Ontario is $50 million, and for some reason, they're not going to tax you. How wonderful. You're 27 years old, plan on living to 100. Because you have $50 million, you walk into the bank, and they tell you that they will give you an interest rate if you deposit all this money in the bank right now. They'll give you 5% annually, compounded monthly. So that means you earned a total of 5% interest at the end of the year, but it compounds every month. That's why the I is different than the R, okay? So we're going to be using the present value formula. The question here is, how much can you withdraw every month? Yeah, every month, and spend everything by the end of your life, okay? So essentially, you plan on spending the entire $50 million the day you turn 100, and that's it for you, okay? There's no more money. So we want to spend everything the day you turn 100 years old. So what we're looking for is we're actually looking for the withdrawals.
So it's birthday.
Okay? So what that means is we have the present value. How much money are we putting in the bank right now?
50 million.
That's right. That's our present value. We're putting $50 million in the bank right now. There you go. So, our present value is $50 million. That's wonderful.
Okay, is it because you're putting everything?
We're putting everything in the bank.
Sir, if you want that one quick tomorrow.
Maybe. I'm doing this so in case I do win the lottery, I can figure out if I can retire or not. So, $50 million. Our interest rate, our R, is 5%. Okay? The compound period. How often is this compounded? How many times a year?
12.
12, that's right. It's compounded monthly. So our C is 12. Okay? So we have that information. We're going to be looking for R in this question. We want to know how much we can withdraw every month and live off this amount.
Sir, did you put the R as 0.05?
Oh, sorry. 0.05 is a decimal. Good. Now we need to calculate I. I is 0.05 divided by that 12. So 0.05 divided by 12.
Is that how much you get a week?
This is how much interest they technically give you every month. It adds up to 5% at the end of the year. 0, 0, 4, 1. Oh, we've done this one before. 6, 7. And the number of compound periods over this life. Oh, that's what we didn't figure out. What are the years in this question?
73.
70,
70.
73 years. So we're keeping this money in the bank for a very long time. So the number of compound periods is years times compounding per year. So that's 73 years compounded 12 times a year. So you're gonna get interest quite a few times. 876 times you earn interest on this. So
But we didn't touch it. We provided everything that I had.
So let's take a look at this. The important ones for our formula. These are the numbers we need to plug in our formula. Now, PV in this case is 50 million. Okay? Is equal to, R is what we're trying to solve. 1 subtract 1 point, that's our decimal, 1.004167. To the power of negative 876. Okay? I know it's a little crammed. We're going to get room in a second. Divided by 0.004167. Now, the goal here, guys, is to isolate R. So my very first step is I'm going to move this decimal to the other side of the equation. When I move it over, it's going to be multiplied by that 50 million. So we get 0.004167 times 50 million.
Why do you
Because we're trying to isolate R. We need to know what the regular payments are. And in the meantime, we're also going to make some calculations over here. We're going to solve this. 1.004167 to the power of 876, and it's a negative number. So we're just equating that little bracket there. We'll try to stay as accurate as possible. 0.02618, let's say. Okay. So we'll equate the left side of the bracket, 50 million times this number, 0.004167, gives us the number 208,350. Oh, that's a nice round number. Is equal to, and we're also going to equate this bracket. We're going to take 1 and subtract that decimal, 0.02618. All right, so that's our decimal now. 0.97382. And finally, to isolate R, we need to bring that decimal to the other side. So we're going to be divided by that decimal. We keep that 208,000. So we have 208,350 divided by that decimal. This will give us our regular withdrawals every month. Put that in right?
Oh,
Wow.
you take that out monthly?
Is that right?
I don't think that's right.
Yeah. So, woohoo, guys, if I win the lottery, I am so retiring tomorrow. According to this, you can withdraw $213,000 a month and still live off that amount of money.
Yeah.
For 73 years, you can do that. Once I would turn 100, then I have no money left. But
Who
every
cares?
month, I can take that amount of money out.
Here's pension.
And
Yeah.
the
Yes,
reason
sir. I
this
was
makes
just gonna say
sense, the reason this makes sense, okay, guys? Remember, when I first put in, this is the one I want you guys to look at. We first put in 50 million, okay? 5% of 50 million. So this is how much interest you're going to earn over the first year, let's say. Now, it's not technically this, but it's close to. 5% of 50 million. So in the first year, it's a little less than this, but you would earn, how much is it? Times 0.05. I think that's it. Yeah. So in the first year alone, you earned $2,500,000 in interest alone.
That's how much you take out.
That's
Oh,
how
no,
much
sorry.
interest you got on top of that 50 million. So that's why we're allowed to take out such large amounts. Okay? We can do that monthly because we're earning so much interest on this $50 million. Okay?